After over 4 months, I finally finished my real burning lightsaber. It works by rotating 4 high-power blue lasers around a telescopic pointer that can be extended and retracted. Due to the phenomena called persistence of vision, it appears to be a solid column of light. On my waist is a box containing the laser diode drivers, step-down converters, and lithium polymer battery. The telescopic pointer mechanism is similar to that of a radio aerial. The 4 brown cylinders are the housings for the 4 2-watt 445nm lasers, and the 2 DC motors spin them via a gear that decreases RPM but increases torque. I use the hole for the fabric end of the telescopic pointer for the laser backstop. At the end of the hill, there's a hole where the 6 wires come out. Two for the lasers, 2 for the motors, and 2 for the button. On the power box is a switch that turns on all the electronics and a switch that turns on the motors. The rectangular hole is where a belt can thread through. I'll take it apart so I can better explain the mechanism that conducts electricity to the laser diodes. On the spinning body are 2 plates of silver foil that the laser terminals are connected to. The upper one is a common anode and the lower one is the common cathode. On the lower plate is a piece of copper tube that stays stationary. The pin here is in constant tension with the copper pipe and acts like an electric brush. Instead of the copper pipe, the brush of the top plate is in tension with the body of the telescopic pointer. Here's the mount for the bottom plate bearing. It sits on top of the silver foil, which is connected to the power supply. The copper pipe in turn sits inside of the bearing and makes contact with it, and therefore the copper pipe is powered. For the mechanism that supplies power to the laser diode, I tried a few different designs. Carbon brushes seemed like a good option, however the voltage drop was too high, and to get the same current I would need a higher battery voltage. I also tried springs instead of the more rigid pins, so there would be less load on the motors, but the high carbon spring steel had too high a resistance, and the 5.4 amps necessary for driving the laser diodes heated it up. The reason this is a problem is that it would get hot enough to melt the PLA plastic. Inside the power box, there's a step-down converter that regulates power going to the motors, another step-down converter that regulates power going to a soft latching circuit which turns on and off the 4 laser diode drivers. Also, there's a BMS to prevent overdischarge and short-circuiting, and a 2.2 amp hour 3S LiPo battery. Next to the switches is the step-down converter potentiometer that controls voltage going to the motors and therefore RPM. All the parts were printed on my artillery sidewinder X1. Since I designed all the parts, it took a lot of prototypes to get the right tolerances and gear size. And for some reason, I thought it was a good idea to put my 3D printer right above my bedroom, which caused a lot of, well, since high-power laser light spinning all over the place isn't exactly pleasant for my eyes, I taped up all the tiny cracks I could see in my laser goggles and also attached a string so I can tightly secure the goggles onto my head. Speaking of safety, it's always a good idea to close all window blinds, close all doors, and also what I like to do is to shine a low power laser all over the place so I can see what reflective surfaces I need to look out for. For this particular build, I need to be careful of the light socket rims, since the lasers are pointing at the ceiling. And now that all the safety aspects are out of the way, it's finally now time to see what my lightsaber looks like. Wonder what it's like in the dark. You may be wondering what can burn. Well, since the lasers are rotating quickly, they don't shine on a specific point for very long and can't heat it up. Like how if you touch a hot object for a short period of time, you won't get burnt. However, it will cause eye damage since the retina are very sensitive. Once the lasers are stationary, when properly focused, they can burn things quite nicely. Like this prototype backstop. Some balloons. Some matches. And a block of wood. Although I'm relatively satisfied with the results, I do have some issues with it. For example, due to the threaded lenses, the laser beams in no way point straight up or are parallel to each other. Also, because of the imperfect lenses and rapidly diverging diodes, the lasers spew out tons of laser light on the side, hence why I used the relatively large backstop. But the disadvantage of using a large backstop is that the telescopic pointer bends, enough even to let the lasers shine outside of the backstop. And no matter how much petroleum jelly I used on the gear, it still somehow managed to sound like R2-D2 screaming. As I said, I'm pretty happy with it, and I'll probably be revisiting the project with a few upgrades, and hopefully more power! As of right now, I'm going to put it in my cupboard, never to see the light of day again. Nah, just kidding, I'm going to harvest its guts for parts.